3, lesson 9. So we're doing application of quadratic functions, the algebraic approach, which just means without your calculator. We're going to do it in terms of solving. The standard form of a function is useful to solve, analyze, and interpret problems whose graphical models are parabola in shape. Complete the following statements for the standard form of the equation of a parabola by y equals a times x minus p plus q. So just review, what's the coordinates of the vertex in terms of the general? PQ. Okay, when A is blank, the maximum value is, so like, when A is what? How do you get a maximum? You get a maximum when your A is what? Negative, right? So it would be less than 0. The maximum value is Q. When A is greater than 0, the maximum value is Q. The equation of axis symmetry every time, no matter what, is going to be x equals p. Whatever p is what your axis symmetry is going to be. Okay, any questions there yet? Simple stuff, hopefully. Hopefully that's the review. Okay. All right. So consider the following information taken from lesson 8 on page 347. Class example 1. The height in meters above the ground of a projectile at any time in seconds is a launch, after launch is defined by negative 4t squared plus 48t plus 3. The biggest thing I said on Thursday is that parabolas, in my opinion, their most basic and most often use of a real life example is gravity. Every time you throw something, it makes a parabola shape because it comes down. So throwing a ball, like shooting a hockey puck, all those things still have a parabola, even though they're flatter versus, like a basketball shot would be more vertical. But complete the square to write h in standard form. So what we're going to do right now is we're going to put this into standard form so we can see what it's doing. Because the thing is we did our calculator for that problem we just did, but if we complete the square, it's right there. It's q, right? So all we have to do is figure that out. So let's go ahead and do that really quickly. So we're going to complete the square on this. So let's review our complete the square steps. So we're going to go negative 4t squared plus 48t plus box, and the 3's out over here. Always move the constant out of your way. Okay, and what do we want to do next, Nick? Do you remember? Good. Take the negative 4 out. We want to get this out. So that gives me, and it's only to these two. Okay, we're not touching the 3. Gives me positive t squared. That gives me a negative 12t plus box plus 3. Okay, Andrew, remember the next step for completing the square? Half the 12, good, which is the negative 6, and then we square that. 6 squared is 36. And what's the step now, Wes? Right, 36 times negative 4, okay, which gives me a negative number, so I'm going to add it. Okay, and it gives me, what's that, 120, 144? Okay, so now it's the put it all together step. We go y equals negative 4 times t minus 6 squared plus 147. So Beth, then what's my vertex? 6 and 147. So is this a min or a max? It's a negative, right? So it's a max at 147. If you flip back to lesson 8, we got that. We got 147. So honestly, this one, it's not going to have every time. This is actually a little bit quicker using the calculator. Okay, that didn't take too long. Okay, so find the height of the projectile after 3 seconds. So how can I find the height of the projectile after 3 seconds? I can plug 3 in for t. Okay, I plugged 3 in for t just like we did earlier. I'm going to get 3 minus 6 squared plus 147. When you calculate that, you're going to get 111. That's 111 meters by the problem. Okay, we already have this. Find the max. That's 147. So y, because the height. When is the max reached? The 6 right there. Okay, 6 seconds. Okay, what was the height of the projectile at the launch? Now this one, it's easier to go back and steal your general form, right? Because to find our y-intercept, we make x 0. Now you can still do that. Okay, I can still put t to be 0 and then solve, but your y-intercept is always that last constant on your general form. So I would suggest if you just convert it from general form, you can still use that. Okay, so you would still have 3 meters. So that means that whatever they were doing here, it left at 3 feet. So that's, to me, it's a good height if they were throwing something. Okay, something else, maybe underhand. I don't know. Okay, so 3 feet would be, or 3 meters. What's that? Like 9.5 feet? 10 feet? Yeah. So definitely not underhand then. Okay, determine when the projectile hits the ground the nearest tenth of a second. Okay, so this is where F, I still think standard form is probably easier. So you're going to set y equal to 0. And you're going to solve. So I'm doing F right here. Okay, so we're going to go -4 times t minus 6 squared plus 147. We're going to minus the 147. Divide the -4. Makes it a positive. And then here, we square root. Okay, and we get 147 is not a perfect square, so it's going to be plus or minus 147 over 2, because I can square root 4. So our last step is to add the 6 over. So 6 plus or minus root 147 over 2. The 6 is an over 2. Okay, and then you're going to do is you put these in your calculator. So please put those in your calculator real quick, and you're going to get 2 answers, okay, because we have plus or minus. So tell me what we get. What was our 2 answers? So you get -0.1 and what? 12.1? Okay, so are those both acceptable answers? Why? Which one do we reject? Negative time, right? We don't have negative time yet. So this one we reject, and that's correct. Okay, what's another way? Let's say that you don't like using a standard form, you don't like solving standard form. What's another way you could have done that? Quadratic formula. You could take quadratic formula from this guy if you want. Either way is fine. Doesn't matter what you do. Okay? Any other questions? Because hitting the ground, let's get back to the basics. Hitting the ground is 0 for your height. So you're finding a 0, so you're finding an x-intercept. Okay? Any other questions there? And then the last there on G, it says, how does this compare to your answers on less than 8? They're the same. Okay, all these answers are the same. All right. Okay, I will say this next problem, maybe highlight. I remember seeing one like this on your summative or midterm. Okay, a rancher has 300 meters of fencing. Okay, with 300 meters of fencing with, has 300 meters of fencing with which to form a rectangular corral enclosure for livestock, one of whose sides is existing wall, so it does not require fencing. So one of these sides we don't need to have any fencing for. So if 2 sides of the rectangle are each x meters, show the area of the corral can be expressed by 300 minus 2x squared. So what we know is we have, actually let's go ahead and steal this here. Yeah. Okay. And here, this is my existing wall. So we don't need fencing here. So we don't need fencing there. We only need fencing these 3 sides. Okay, that's the only 3 sides we need fencing for. And then they tell us that the short sides are going to be our x sides. And so it wants us to figure out why can we represent the area as 300 minus 2x squared. Well, remember, we know area of a rectangle because it's still area, it's still length times width. Even though we only have one length, doesn't matter, it still has an area. So how can I figure out the length of the, like, what's this in terms of x? How much fencing do we have? 300. Yeah, we have 300 fencing, and we have two sides of x that we would not count for this side, so it would be 300 minus 2x. That's how you'd represent that side. Does that make sense? Because it's the fencing, the total fencing minus the two sides you don't know to get the third side. Okay? So that's 300 minus 2x gives me that missing side. So the area, 300 minus 2x times x, length times width. And that's how we get this answer here. Okay? It says use the method of completing the square to determine the maximum area possible. So we're trying to maximize the area. Well, let's take a step back. Let's make sure we understand. Is my x squared positive or negative? There. It's negative. So maximum makes sense, right? I have a negative a, so I have a hill. So, okay, we're good with that. So we're finding the maximum. So use the method of completing the square. So I need to complete the square on this. Okay, so I'm just going to put y. I'm going to put it in a different order. I don't have any constant to move, so it's just like that. There's no constant to move, just leave it right there. Okay, what do you want to do first? Melissa, what do you want to do first here? Good, take the negative 2 out. Okay, good. And what do you think now, Evan? Okay, good. Square that, and that is 5625. Okay. And we have to multiply that out here, which gives me a negative, so I put a positive. Shrink this down. Okay, so that's what I got shrunk down to. Why did that help us? Why does that help us? Gives us our max. What's our max? Right, max area comes from right here. 11,250. And I'm sorry, I do put commas. You don't have to. I know some math teachers hate that, but that's just from my prior experiences. Okay, state the dimensions of the rectangle that gives you the max area. So what are the dimensions of the rectangle? Well, we have state dimensions, so yeah. So what is the point of what's the point in which we get the max area for x? What's our p? 75. That's the x value, right? So 75 would be right here. Does that make sense? So then what would that make? What's 2 times 75? So what's 300 minus 150? So your dimensions would be 75 by 150. Okay, we use all the fence. Okay, it's all used up. Okay, just got 2 more examples here. We feeling okay? All right. All right, example 3. Ashley was asked by her math teacher to find two numbers which differ by 8 and whose product is a minimum. Okay, so larger number. So if x represents the smaller number, write the quadratic expression in x for the product of the two numbers. So if x represents a smaller number, then the other number's got to be what? Larger. So it'd be x and, so you'd have x plus 8 would be the larger number. The smaller number we would just have as x. X times x plus 8. So the product of those two is a quadratic, would be x squared plus 8x after I multiply these here. Write the product in completed square form. So go ahead, you guys go ahead and complete this square on that. I'll let you guys do that for a second. I'm going to take this off. Oops. All right, how do we do on that? Do we get it? Yeah? Okay, good. So when you do that, you'll get y equals, and then I'll run through it real quick if you didn't get that. Minus 16. Let's make this a better square. Okay, so we had x squared plus 8x. So with all we had to do, there's no constant, so just add the box. Half of that's 4. And it was pretty much that simple there. Determine numbers and the minimum product. Okay, so what is our min? Because this is, our A is positive, so this is going to be a parabola doing this. Okay, so what is our minimum product? Yeah. What's that? Negative 16? Yeah, negative 16. So what's your P? Right, negative 4, negative 16. So what number, what's the two numbers then? If negative 4 is my x, what's the other number? That's our smaller guy. What's our big number? Right, x plus 8. So what's negative 4 plus 8? 4. Negative 4 and 4 are your two numbers. Does that make sense? And that makes sense because 4 times negative 4 is negative 16, and 4 is 8 bigger than negative 4. Okay. All right, moving on here. Last example. We'll get one little thing before it, though. Okay, extension, the vertex formula. So all I'm going to show you from the vertex formula is this. Another quick way, if you have something in general form, a quick way to get your axis of symmetry is this, negative b over 2a. Okay? Negative b, so whatever your b is, over 2 times a will get you your axis of symmetry. So that's all I think I'd take away from that, because if I get my axis of symmetry, I would just plug that in to get my y. Okay? But you can also do this as well. Okay, this is just a pattern. You kind of looks like what? What's that kind of look like a little bit? Yeah, it comes from the quadratic formula. That's what they're showing you right there. Okay, but again, negative b over 2a will get you the axis of symmetry. Okay, and your x value for your vertex. All right. Okay, so use the appropriate procedure to determine the coordinates of the vertex of the graph. Each of the following functions state the max, min value of each function. Okay, so this is how we want to do it. So you guys tell me. So this right here, I have A. Do I have any work to do here? No, I do not. It's in standard form. Okay, it's already in standard form, so I already have my vertex. It's negative 5, 8. Okay, is this a max or a min? Min, and where's the min at? It's at 8. Okay, and that's all they ask for. But if you want, AOS is negative 5. If you want your axis symmetry. Okay, so let's try using that formula up there real quick. Well, because it doesn't say we have to put it in standard form, so let's try that formula up there. Let's go negative b over 2a real quick. We know that negative b over 2a is going to equal p. right? That's what we talked about above, little shortcut. So that's going to be negative 12 over negative 2 times 2 is negative 4. I get 3. So I know my vertex is 3 something. To figure the other one out, you can use the other one if you want. I prefer just to put it back in just because that's me, but do whatever you want to do. So 3 squared is 9. That's negative 18 plus 36 minus 13. That gives me 5. So I get 3, 5. Okay, and so lastly, that's my vertex. And is this a max or a min? Max, good, because the negative. So max at 5. AOS, axis of symmetry, x equals 3. And that will be it. Okay, oops.